Today I'm going to show you how I modified a $45 15 volt 25 amp switch mode power supply unit to make the voltage output adjustable between 6.5 volts and 15 volts. By having the wide range of voltage output, I'll be able to power many devices and charge 6 volt or 12 volt lead acid batteries, charge 2S or 3S lithium ion batteries, and 2S, 3S, or 4S lithium iron phosphate batteries. What I'm about to show you can be used on a wide range of 120 volt or 240 volt input power supply units. This unit here is made for a 220 to 240 volt input. For my viewers in the United States, you're going to need a 15 or 20 amp 220 receptacle in your shop or garage in order to use this power supply. If you're going to operate this unit at 240 volts, you can expect right around 15.4 or 15.5 volts as your regulated output. And if you operate this unit using 220 volts, that output is going to be right around 15 volts. 15 volts as well as 15.45 is just a little bit too high for charging a lithium iron phosphate 4S battery or even a lead acid battery in your vehicle. This unit also has USB Type A ports. I don't intend on using them, but we will test one or two of them out to see how much power they can output. And over here you can see it uses banana jacks. So you're going to have to take your cables. Right here I made a couple using these clamps with this 10 gauge stranded wire. The other end, you can see the banana jacks. They're very inexpensive. You would strip the wire and slide it inside, and there's a set screw to secure the wire to the connector. Now, if you do not want to use a banana jack, what you can also do, and I'll show you in a minute when I open up the unit, you can cut this wire and then strip off about 1/4 of an inch or 6 millimeters of the end of the wire. And then very carefully, once this cover's been removed, you're going to place a vacuum cleaner, the end of the nozzle, right against the back side of each one of those ports. So you would do the top two because they're easy to get to. And then with the vacuum running, you're going to take a drill bit, the same diameter or slightly smaller as the hole in the banana jack, slide it in, and you're going to drill out that very thin metal backing inside that jack. When you do that, you'll be able to slide the stripped wire directly into the hole and solder it directly to the board. There will be no need for the banana jacks. Now if you take a look right over here, you're going to see a knob that I added. That knob is going to allow me to adjust the voltage output for this power supply. And the rest of the unit, nothing special, just two halves sandwiched together. Here's a look at the back side of the unit. You have the end of the cable. Here is hot, and the middle one is your ground. And there's a problem with this unit which is very easy to fix, which I'm going to show you in a minute if you do decide to copy what I did in this video. You have your on-off power switch and a 40 millimeter 12 volt case fan. And a quick look at the bottom. I just put these pads on it to keep it from sliding around. In order to use this cable with my 220 receptacle, all I did was cut off the end that came with the cable, and I purchased this inexpensive end. It was only around, I think, $4. It's a 20 amp 220. It didn't have to be a 20. I could have used a 15, but the receptacle in my shop was a 20 amp receptacle. Before I open up this power supply to show you exactly what I did to make the modifications, first let me connect this up to my load tester to show you how well it works. Power supply is connected up to my electronic load, and if you take a look right over here, you're going to see that I made this aluminum jumper plate. It connects the two reds, that's channel 1, channel 2, and there's another one at the bottom that connects the two blacks. The purpose of doing that, each one of these only allows up to 20 amps to be tested, so I want to be able to test up to 25, so I'll probably do 15 amps on this one, and I'll do 10 on the other side. So to get started, let's power this up. It's connected to 220. So let's adjust the voltage output first. It's showing 14.5. You got to turn this very slow. That's the maximum, 14.65. If I go really slow, You can see it better right over here because the red might be a little bit of a problem seeing. 14.5. And it's really nice having this. So if I need to do something at 13.5 or 12.6 like a car battery, or 12 volts or 10.8, I can do it. Just keep going lower. So right now we're right around 12 volts, 11.9, 11.974. Now there is one thing I need to tell you when you make this modification. Let me put this all the way down. The lowest it goes, 6.42. That's the lowest it's going to go. Now the fan is still running, but it's running at a slower speed because the fan is intended to be run at 12 volts. So if you're going to use this below 10.8, it's a good idea to not use the 25 amp full load unless you decide to do the additional simple modification that I'm going to show you in the video. So right now it's 6.44, so let's put it all the way back up. Now what I really like about this unit, once the load is placed on it, you're going to see how many amps are flowing. You're going to see the power output as well in watts. Right here you can see channel 1, 15 amp setting. If I push that button, channel 2 is set for 10. So let's put this back. Let's turn on channel 1. We now have 15 amps on here. Drop just a little through the wiring, the voltage. You can see power 218, volts 14.5, amps 15.1. So now I'm going to add on channel 2. Now we're going to be at 25. Now you can see power, volts 14.6, amps 25, power 364 watts. So it definitely has the rated output. You just heard the fan for this turn on to cool it. We're now 14.6, 25.1 amps, power 365 watts. Now just in case you're wondering, 14.635 is the highest voltage setting for this unit the way I have it set up. And I could have had it go to the full 15.5 that this unit showed when it's plugged into my 240 volt receptacle. It's a very simple modification. It's just a matter of changing the value of this potentiometer from 50K to 100K, or 100,000 ohms. You'll see in a minute exactly how it's connected up. Now let's lower this to 7.2 volts. That's good. Now I'm going to put on the same load just to demonstrate that the high current output is there regardless of the voltage level set on the unit. So let's go push channel 1 on, and let's turn on channel 2. 25 amps right there. 180 watts, 7.2 volts, 25 amps. So no problem there, but unless I modify this fan to work faster at the lower speed, I would not recommend operating it that high of a level of current at the lower voltage. So let's turn this back off on both. I now have the electronic load connected to the USB Type A port, set for 2.25 amps. You can see the open circuit voltage is 5.1. Let's power it up and see how well it takes this. Let's see what the comparison is. It says 2.2 amps. That's almost 11 watts. That's doing pretty good. 4.678 at 2.25. So it can handle 2.25 amps. And that's showing 2.29. And this says 33 watts. The watts are way off. I don't know where they got the wattage from. But I know that this display is extremely accurate when you use the high current output with the banana jacks. Okay, let's open up the unit. On the rear, you got to remove these 4 screws, one at each corner. and you won't have to worry about this, but I do. There's a set screw in here. Just loosen it and pull the knob off. Take the needle nose and just loosen that nut. Just a little bit, that's good. 4 screws here as well. Alright, so this just pops right off. This pulls away. Okay, let's take this cover off. Right over here is what I added. Potentiometer. And it connects to this board. Now I'm going to slide everything out of here. Lift up. And just slide out the tray. The first thing you want to do before touching anything is make sure that these capacitors are bled off. Let me show you how to do that. Once you flip it over, you're going to locate the area for the high voltage electrolytic capacitors. One is right here. The other is between these 2 points. Using a capacitor discharge tool, which is nothing more than a 20K or 20,000 ohm resistor, rated 5 watts, you're going to go right between those terminals and hold it there for a few seconds. The same way. After that's done, it's always a very good idea using an insulated tool like this needle nose to go just between these 2 points to make sure that they're shorted. Reach in, go like that. You also want to do the poly capacitor for the AC line. It's this one right over here. See it? That's the capacitor. Once you do that, it's safe to handle the board without getting a shock. Some of you are probably wondering, why is that green wire going through the board and connecting to this point right over here? And there is a reason for that. The first thing I did before making any modifications was to check if the unit was properly grounded. And you can see this pin right over here, the bottom one. I checked between the bottom pin and the metal housing, and there was no continuity. This pin right here goes to this entire plane or entire area, and you can see it goes right there, that little area of solder, as well as right over here. And the intention was, when you slide this inside the aluminum housing, this point here and this point over here was to make contact, grounding the unit. That was a very poor way of doing it. So what I did is I went to the center pin of the power jack, which is right here. I soldered a green wire, which is ground, wrapped it right around, and inserted it through the hole. And when you look on the opposite side, you can see the green wire comes right through between these capacitors, and it goes to this ring connector, crimped onto the end of the stripped wire and soldered. And the intention is to place it right between this aluminum faceplate and the housing before the screw goes in. When you tighten this down, you end up grounding the entire housing. Using a flat file, I ground down just enough of the corner to remove the anodized finish and recess it so when the ring connector is placed between and the screw is tightened, everything goes flush. When looking over this unit, I did find one other problem that I wasn't too happy with. You can see these 2 wires, they're fairly rigid, so unless you're in here moving them around, they're not going to go anywhere. It's the temperature sensor, it's a thermistor, and it was just pressed right up against the heatsink. I could have very easily just grabbed it and pulled it away. So that was a very, very lousy way to do it. So what I did to correct it is I took some thermal glue and I applied some to the thermistor and the heatsink, and by doing that it's now bonded and it will not go anywhere. So I just wanted you to be aware of the grounding problem with this unit and the thermistor. In order to modify the power supply, I'm going to show you which components to look for and what to do. Now the 2 components that you're going to look for are going to be located not on the AC side, which is over here. It's going to be on the DC side. And right over here you can see this board where I tapped into to wrap all the way around with the potentiometer. Let me explain this to you in detail and then we're going to come back to the power supply. The way switch mode power supplies set the output voltage is using a reference voltage. And right over here you can see Tl431. It's this TO92 component. The left pin is the reference pin. The middle is the anode or positive, and the far right is the cathode, which is negative. This component is also available in an IC package like you see right here. It's nothing more than a Zener, Zener, or Zener diode, depending where you are in the world, how you pronounce it, and you adjust the value using resistors. I'm going to show you in a minute how it looks like when it's set up. These components are commonly found in smaller switch mode power supply units. The other component you want to look for is this one right here, a Tl494C. It could be a 494I, 494M, or Y. It's a pulse width modulation control circuit, and what you need to do is identify the pins on them, and you can see right here, pin 1 starts at this end, goes all the way down to 8, and then 9 goes around, and 16 goes to the top. Over here it says ref, output control. These are typically connected together, which I'll show you in a minute. But the pin that I adjusted the value of the resistor on was right over here. It says 1N minus or negative, pin 2. This is where we're going to make the change. Let's take a look at this schematic for this one first since it's closer, and then at the bottom of the page I'll show you what to look for if you have a Tl431. Hopefully you can see this on your phone. It's kind of small. If you can't, I suggest before doing this on your power supply unit that you look at this closer on your computer. This component, the Tl494, is used in many different switch mode power supply units. So pin 2, you can see there's a resistor right here, and another resistor next to it. What I did is I located the resistors inside the power supply unit that I have, and with the power on, I took a 10K resistor and I placed it right in parallel with the soldered points for the resistor. When I did that, I took a look at the front display to see if there was any change in the output voltage. If there was none, then I went on to the next one, which is right over here. And when I did that one, the display changed. Now if the voltage went lower, placing a 10K in parallel with the existing resistor, you know that you're going to have to keep increasing the value of the resistor to get the voltage to go lower and lower. If you want the voltage output to go higher, then the only thing you could do is desolder the existing resistor tested using this resistor and replace it with a resistor that has a higher value. It's fairly simple to do, but you do have to be very careful. I recommend using a rubber glove to hold the end of the resistor when you start probing around. Make sure your other hand is in your pocket. Do not touch anything. You're dealing with very high voltage. If you're even slightly uncomfortable doing this, do not do what I'm showing you in this video. If nothing happens when you're experimenting over here, you may want to try placing resistors in parallel in this area as well. You want to see that output voltage go higher or lower. Right here is a typical setup for the Tl431. This component I just showed you, I'm on the reference pin, number 1. Number 1 comes off and it goes to a voltage divider. Usually these are fixed values. This one's fixed and that one is variable. So what you want to do is take the resistor like I showed you, start with a 10K, and just place it in parallel with either this one or that one to see if you get a change. If you do, keep adjusting the value until you get the desired voltage output. When I was done testing this power supply unit, I discovered that I needed a 47K resistor placed in parallel with the other resistor coming off of pin 2 on the Tl494. Using the 47K value and having 240 volts AC input power in the United States, dropped the 15.5 volts down to the 14.6 that I wanted. Instead of using the 47K to have the fixed voltage output, I decided to use a 50K potentiometer. It's a linear taper, and I placed it in series with a 1/4 watt 2K or 2000 ohm resistor. And what it's going to do, when this is set to the highest position, I'll have 47K plus 2K, which is 49K. When this is set to the lowest position, the wiper, pin 2, will go all the way by number 1. So effectively this is just a short circuit, 0 ohms, and I do not want to have 0 ohms placed in parallel with the resistor coming off of pin 2. So that's why I have the 2K here. The value will never be lower than 2K in parallel with the resistor coming off of pin 2 on the TL494. And right here you can see pin 2 and 3 are connected together. One wire comes off that side, and pin 1, another wire on this side. You could also do it, pin 1 and 2 together with the wire, and 3 connecting to the fixed resistor. My power supply, as you saw, goes to 14.6 because I did not have a higher potentiometer value on hand. If I used a 100K right here with the 2, then the voltage would be 15 to 15.5 at the high end, and I would have the same 6.5 volts at the low end. Just to show you what I mentioned earlier with the banana jack, you would insert the drill bit and drill out the very end over here. There's just a little tiny hole in it. Hold your vacuum hose behind it. You don't want any filings landing on the circuit board, and you're going to drill straight through. Once that happens, insert your wire, and then you could use a 40-watt soldering iron to solder the copper wire to the board. To perform the modification on this side of the circuit board, you're going to need to remove the heatsink. You're going to loosen the Phillips screws enough, but you do not want to have this piece of metal right here fall off. You want to keep it attached to the screw, and you can see right over here between the component and the aluminum heatsink, a thermally conductive pad. Do not tear those. Be very careful when you pry the component away from the heatsink. With the heatsink out of the way, you can now see the board very clearly. You can see the PWM integrated circuit, and if you look right over here, this is pin number 2. I follow the trace over to the resistor, and you can see that resistor has solder on each side of it, connecting a wire that leads to the potentiometer. To show you how I identified this as the correct resistor, all I did was take the resistor, as you see right here, hold it carefully using a rubber glove, then I touched the leads to each side of the resistor to see if there was a change in the voltage output. Once everything is finished, you're going to reinstall the heatsink, and you're going to make sure the heatsink has at least a 2mm space underneath it between the heatsink and the board. If you don't leave a space, the circuit board will not slide back into the aluminum housing. And to make the fan run at full power, regardless of the voltage setting on the power supply unit, you can use what you see right here. This is a transformerless power supply. What this is going to do, you're going to connect this to each leg of the AC line, which is 240 volts. So 120, 120. If you're in Europe, it may be 220 and a neutral line. In my case, both are 120 volts. So right over here, you can see is a pico fuse, 200 milliamps, and that goes directly into this capacitor. This capacitor here is rated 630 volts. You do not want to use a capacitor that's lower than 400 volt rated. The reason for that, a 120 volt AC line has a peak of 170 volts. So if you have a 240 volt line, you're going to have a peak of 340 volts. So this one here is rated 630. The capacitor on this side is rated 400. Both can easily handle that. And if you're wondering why I have two in parallel, it's because I didn't have the correct value. The correct value required is right around 0.7 microfarad. If you have one that's close enough to 0.7, you can get by using one. If you have two capacitors, you can connect them together to get the value that you need. The other side, right over here, ties into this component. This component is a very small 700 volt rated bridge rectifier. So you have alternating inputs, one on the left, one on the right. So from the capacitor, it goes into the alternating input on this side. And on this side, it goes to this resistor. Now, normally I would use a 1 watt, 100 ohm rating resistor. I didn't have one laying around. I only had this 3 watt, 62 ohm. The purpose of this is to limit inrush. So try and keep it around 1 or 2 watts and 100 ohms, and you should be fine. The positive and negative on the bridge rectifier connect up in parallel with this 35 volt 100 microfarad electrolytic capacitor. The purpose of that is to smooth out the ripple on the output. You would take the positive from the cooling fan connected to this point right here, and the negative from the cooling fan to the opposite side. With the transformerless power supply installed, you can hear the fan running very good. And when I lower the voltage now, the speed is not going to change. .4 and plenty of cooling. And guys, that is it. I hope you enjoyed this video. If you did, be sure to rate thumbs up, share, and check out my extensive video playlist for many other videos of interest to you. Thank you very much for watching.